Welcome to this video on scatter plots and correlation, finding and using critical values. In this video, you will learn how to find the critical value for a linear regression using a table of values and the sample size n, and use this critical value to determine if the linear correlation coefficient r for a linear regression indicates a meaningful relationship between two variables. What is a critical value? Critical values are used in many places in statistics. In the context of linear regression, we use critical values to determine whether the linear correlation coefficient r is meaningful. The critical value depends on the number of data points n or sample size of the data. Critical values and sample size. Let's examine the case of a dataset with just 2 data points. Suppose we measure the ages of 2 babies in months and their respective weights in pounds. Here's the data we collect. A baby who is 1 month old weighs 9.8 pounds, and a baby who is 10 months old weighs 20.1 pounds. Since there are only 2 data points, and it takes 2 data points to form a line, both of these points will lie exactly on the regression line, suggesting that we have a perfect fit, or r equals 1. Does that really mean that we have a perfect model or a perfect line, or is something else going on? The fact that both points land on the line is solely due to the fact that we only have 2 data points. In fact, StatCrunch and other statistical software packages will require that you have at least three data points in order to create a linear regression equation. Here is a table of critical values that is dependent, as you can see, on our sample size n. Notice that the critical values in this table, which is taken from Appendix A of Table 2 of your textbook, start at n equals 3. Therefore, we have to have at least 3 data points in order to create a line of best fit. What happens to these critical values as our sample size increases? Well, as you can see, these critical values will decrease dramatically as our sample size increases. Notice that values beyond 30 are not represented in this table. Why is that? Pause this video and see if you can figure it out. The answer is that, as you can see down here, the critical value associated with a sample size of 30 is 0.361. This is already a very low correlation coefficient to begin with. And so for sample sizes larger than 30, we don't worry about or bother with finding a critical value. We just assume that our correlation coefficient is relevant and significant. So again, we only have to check for critical values when we're dealing with a small sample size or n is less than or equal to 30. To be considered significant, the linear correlation coefficient r has to be larger than or greater than this critical value. Let's do a few practice examples here. Suppose you have a data set with only 6 data points. According to the table, that means that our critical value is 0.811. Which of the following linear correlation coefficients would be considered based on comparing them to this critical value? 0.75, 0.8, 0.9, and 0.95. You can pause this video and write down which of those you think are significant based on this information, and then unpause it to see if you are correct. Here's a table of values. As you can see, 0.75 is less than the critical value. Again, to be considered significant, the linear correlation coefficient has to be greater than the critical value. Since 0.75 is less than the critical value, this would not be considered a significant correlation or a significant relationship between the two variables being studied. What about 0.8? Well, 0.8 is still smaller than or less than 0.811. So again, since this is smaller than the critical value, we would not consider this a significant relationship between the two values. How about 0.9? Well, 0.9 is larger than 0.811, so we would consider this to be a significant relationship between the two variables. And likewise, 0.95 is larger than 0.811, so again, you would consider this to be a significant relationship between the two variables. Let's do another example. Suppose you have a data set of sample size n equals 10. Using a StatCrunch or similar software package, you find a correlation coefficient of r equals 0.8. Is this or does this represent a significant relationship between the two variables? Well, as you can see from the table, our critical value is 0.632. Zero point 0.8 is larger than our critical value of 0.632. Therefore, this does represent a significant relationship between the two variables in question. Let's do another example. Suppose you have a data set of sample size n equals 3. Using StatCrunch or a similar software package, you find a correlation coefficient of r equals 0.995. Does this represent a significant relationship between the two variables? Well, let's see. Our critical value is 0.997. As you can see, 0.995 is still smaller than the critical value. Therefore, since our linear correlation coefficient is smaller than the critical value, there is not a significant relationship between the variables. Let's do one last example. Suppose you have a data set of sample size n equals 30. Using StatCrunch or a similar software package, you find a correlation coefficient of 0.6. Does this represent a significant relationship between the two variables? The answer is yes. 0.6 is larger than the critical value from the table, so therefore this does represent a significant relationship between the two variables. Having watched this video, you should now be able to find the critical value for a linear regression using a table of values in the sample size n, and use the critical value to determine if the linear correlation coefficient r for a linear regression indicates a meaningful relationship between two variables.